Now we're going to take a look at default parameter values. Let's suppose that in our employee class there's a standard rate that most employees get automatically when we hire them. We would like not to have to specify the rate unless the rate is some non-standard amount. Likewise, let's suppose for managers that the rate, title, and budget are standardized for new managers that we hire. So again, we only want to have to specify rate, title, or budget for manager objects for which these are unusual values. What we can do is to specify in the declarations of these functions in the header. Notice that these default values have to be declared in the header so that any application using the class will know what these default parameter values are. And we specify a default value for a parameter by using an equal sign followed by the default value that we want to have. So here on slide 10 at the top is our employee class definition. This is in the employee.h file. And we've modified our constructor declaration so that when we create an employee object, we are required to specify a name for the employee, and the name has to be specified either as a string object or it can be specified as a string literal, which will automatically be converted into a string object. But the rate is now optional. If we specify a rate, a double value for the rate, then that value that we specify will be used. But if we don't specify a value, then the employee will get a default rate of 50. Let's take a look at our program on slide 11. Here we see that we're including the employee.h header. So in our program, the compiler will understand what an employee is and also will understand that the constructor has a default value for the rate. In this program, if I declare Alex as an employee object, I have to specify the name. So here I've specified Alex, the string literal, which will automatically be converted into a string class object. I have not specified a rate for Alex though, so Alex is going to end up with a rate of 50 by default. In the case of Bob, which is another employee object, I have specified both the name and a special rate of 63.1. So in this case, Bob's rate is set to 63.1 and the default value of 50 is ignored. Here in the manager class, which is defined in the manager header file, for the constructor, I'm still requiring that a name be specified for the manager. That name will simply be passed down to the employee class constructor. My default rate I'm specifying as $70 per hour, again using an equal sign and a value. And likewise, the title is going to be manager by default, and the budget is going to be $500,000 by default. So here in my application on slide 11, I've created a manager object named Carl, and all I've specified for Carl is the name. So Carl's rate is going to be 70 by default, Carl's title is going to be manager by default, and Carl's budget is going to be $500,000 by default. When I then call the print functions on these three objects, Alex, Bob, and Carl, as we see here on slide 12, Alex's rate is 50, which is the default value. Bob's rate was 63.1, which is the special value that we specified. And for Carl, we have the default rate of 70, the default title of manager, and the default budget of $500,000. Okay, let me back up to slide 9 for a moment. It turns out that non-member functions, that is top-level or global functions, or file, local, or module functions, that is top-level functions declared static, can also have default parameters. Default parameters are convenient, but they're not merely convenient. For example, let's suppose you wrote a graphical application, but in your initial application, all of the drawings were in black. So you have these draw functions that don't take an argument, and when you draw a circle, you get a black circle, and when you draw a square, you get a black square, and when you draw a line, you get a blank line, and so forth. Now you come along later and decide that you want to add the ability to draw objects in color. So you add a color parameter to your draw function, but you already have code written using draw with no argument to draw things in black, and perhaps many people that you're working with have used your preliminary code to develop applications that draw black graphs. Well, it's not a problem, because now you can declare a default parameter of black in your updated draw function, and all you have to do is recompile all the old code that was calling draw with no argument, and those programs will still get the black stuff by default that they were expecting. New code that you write can specify colors, red, blue, purple, what have you. Now, as a picky annoyance, here on slide 13, we're showing that you're only allowed, when you specify a default parameter value, to use an equal sign and a value. You cannot use the parenthesis notation, and you cannot use the curly brace notation. So this is just one of these nasty picky things to be aware of. And furthermore, to compound the picky silliness of this, notice here on my left-hand slide, I have an employee constructor declared with a default rate of 50, but in the member initializer list for the employee object, I have to use parentheses to specify the initial values that I want each of these members to have. So I'm required to specify a name, and that name will get used to initialize the name member. Optionally, I can specify a rate. If I don't, I will get 50 by default as the value of my rate member. Otherwise, whatever value I have specified will be used as the rate. And then the ID is going to be set using this next ID. Okay, so you have to use an equal sign when you specify the default parameter value that you want. You have to use parentheses in order to specify the initial value that you want a member to have. If you attempted to use parentheses for your default parameter, that would be an error. And as many of you have been burned by, if you use an equal sign in your member initialization list, that's also an error. So just more picky stuff to know. Okay, and then one more little piece of pickiness on slide 14. The matching of default parameter values is strictly from left to right. The data types of the parameters don't play any role. You can't skip values. So what you need to do is to specify your parameters in order from left to right, from most likely to be changed to least likely to be changed. And that way you can use default parameters as much as possible. For example, here Doug is a manager. We have specified the name for Doug. We've been careful to make the name the leftmost parameter in the constructor. So Doug gets a default rate of 70, a default title of manager, and a default budget of $500,000. For Ed, I've specified the required name, and I've specified 72.5 as the rate. That is, I've specified 72.5 as the second argument, and that will always be matched up with the second parameter, which is the R parameter here that's used to initialize the rate data member. Ed gets a default title and a default budget. Fred has a name, a rate, and a title with a default budget, and finally Glenn has a name, a rate, a title, and a budget, all explicitly specified. Now, if I wanted Hal here to have the name Hal and the title Boss, and I wanted to use the default rate and the default budget, well, I'm out of luck. Because if I try to initialize Hal with a first argument of the string Hal and a second argument of the string Boss, the compiler is just going to complain to me, hey, that second argument has to be a double. You can't specify a string where I'm expecting a double. You might think, well, that's okay, I'll just leave that second argument unspecified. That is an error as well. You have to specify a value for an argument. You can't simply have two commas in a row. Okay, so this default parameter stuff is not perfect. It does have picky syntax details to keep track of, but it is nevertheless convenient and can help you with some maintenance issues when you're trying to modify old code.